Good morning to all students. Today I discuss Cayley-Milton theorem. You know that one. What is the Cayley-Milton theorem? That means the characteristic equation and characteristic polynomial. You know that one. Okay. First, one by one, I discuss about the Cayley-Milton theorem, and finally we find the A inverse. Okay, how to finding A inverse. Okay, what is the formula of A inverse means? That is the A inverse is equal to adjacent of A divided by determinant of A. That is A inverse. Okay, in your syllabus, that is the verify the there is the 2 mark question. Verify the Cayley-Hamilton theorem means you write only a theorem. Okay, then that not necessary to discuss that theorem. Okay, see here, I share the screen. It is the Cayley-Hamilton theorem. Okay, see here, Cayley-Hamilton theorem means that is the first characteristic polynomial. For characteristic polynomial means a minus lambda phi. You know that one. What is the a minus lambda phi? Okay. A is the given value. After that, lambda means that constant. I mean that is the identity matrix. That is 1 0 0 1. That is the identity matrix. Okay. Here, this is your Cayley-Hamilton theorem. Okay, this is 2 mark question. That is the Cayley-Hamilton theorem. Prove the Cayley-Hamilton theorem means that theoretically, this is your 2 mark question. You write only a statement. Cayley-Hamilton theorem means every square matrix means that is the 2 rows, 2 column, otherwise 3 rows, 3 column. That is the every square matrix satisfies the characteristic equation. Characteristic equation means you know that one, that is the A minus lambda of I. That is characteristic equation. Okay. Now see here, every square matrix satisfies the characteristic equation, or otherwise see here, if A minus determinant of A minus lambda phi is equal to that 0. Okay, that is characteristic equation. Characteristic polynomial means that matrix of A minus lambda of I. That is characteristic polynomial. Okay, in your fourth experiment, this is also same. Fourth experiment, verify the Cayley-Hamilton theorem is there. That is practical. Okay, see here, if determinant of A minus lambda phi is equal to A naught lambda of n. Okay, plus A1 lambda of n minus 1 plus A2 lambda of n minus 2 plus so on, that plus an minus 1 lambda plus an is equal to 0 is a characteristic equation of A. Okay, then A naught, then that is the small a naught, then capital A to the power of n plus A1 capital A to the power of n minus 1 plus A2 capital A to the power of n minus 2 plus so on, then plus a n minus 1 a plus an is equal to 0. This is your 2 marks question. Okay, then proof me this one. This is 5 marks. Okay, video. See here, this is your proof. First, you know that one. What is A inverse? Here, once again I explain, every square matrix is satisfied the characteristic equation. Characteristic equation means you know that one, that is determinant of A minus lambda of I is equal to 0. That is characteristic equation. Okay, finally you write this is A naught a to the power of n plus a1 a to the power of n minus 1 plus a2 a to the power of n minus 2 plus so on an minus 1 into capital A plus an is equal to 0. Okay, this is for 2 marks. Verify the Cayley-Hamilton theorem means 2 marks means you write this much. Okay. Suppose proof means here this is the proof. First we take that is the you know that one A inverse is equal to I. That is identity matrix. Okay. See here First you take the A is inverse equal to I. Okay, you know that one. Then A is equal to, if A inverse come to this side, that is A inverse, that is A into, and what is the I into A inverse? A inverse means, you know that one, that is A inverse formula, that is the adjacent of A divided by determinant of A is equal to I write as it is. Okay, after that A into adjacent of A, this determinant comes to this side, means that is the multiplication, that is determinant of A, then dot, that is the identity matrix. Okay, after that you go to the simplification. Okay, A minus lambda phi. Okay, you consider A means that is A minus lambda phi. After that adjacent of A means you consider A means you write A minus lambda phi. Okay, after that A minus lambda phi into that adjacent of A as it is right here. A means next you write A minus lambda phi, that is equal to, what is the A? A means A minus lambda phi into I as it is right. Okay, suppose A adjacent of A minus lambda phi is equal to B. Okay, suppose A minus adjacent of A minus lambda phi is equal to B means, then so that the equation 1, this is the equation 1. Okay, see here, that is A minus lambda phi as it is, then adjacent of A minus lambda phi means we consider here B. That's why I write here B is equal to, as it is, A minus lambda phi into I write here. Okay, next come to here, that is the A minus lambda phi. I expand this one. This is A naught lambda of n plus A1 lambda of n minus 1, A plus A2, then lambda of n minus 2, then so on, A n minus 1 lambda plus an, okay, into I. Okay, after that you write A minus lambda phi as it is. Okay, this one, then B into, okay, what is the B value? B naught, I expect this one, B naught lambda of n minus 1 plus B1 lambda of n minus 2 plus so on Bn minus 1 lambda plus Bn minus 1 for n B of this B of n minus 2 lambda plus capital B of n minus 1. Okay, see here, this is the equation. See here the continuation, I write here. Okay, I write same that one only. Okay, what is that one? A minus lambda phi into B naught lambda of n minus 1 plus B1 lambda of n minus 2 plus so on B of n minus 2 lambda plus capital B of n minus 1. Okay, that is the previous page. Okay, I write here. Then that equal to, that is the A naught, then lambda of n plus A1 lambda of n minus 1 plus A2 lambda of n minus 2 plus so on A of n minus 1 lambda plus an is equal to an into, that is I. Okay, this is A of lambda minus I. Okay, next see here, since the RHS of the degree is then n. Okay, then B must be a polynomial of degree of, that is n minus 1. See here, this is the B is n minus 1 and that first RHS side, that this is RHS side, that is n. Remember that one? RHS of degree is n and B must be a polynomial of the degree n minus 1. This is n minus 1. Okay, this is n. Remember this one. Okay, then equating the coefficient of like terms. Like terms means that is the, I write here, that is capital A of B of n minus 1 is equal to n of I. This one equating. Means like term means you take A, you don't confuse this one, you only see this one. A of B of n minus 1 is equal to n into I is equal to A of B of n minus 1 is equal to the same. Okay. This is the first term. Okay, after that, see here, this is the first, this is second, and this is third. Okay, I explain here only A of B of n minus 1 are right here. Next you write A into B of n minus 3, A into B of n minus 3. Means n minus 1, n minus 2 and n minus 3. After that minus of, you take here B of n minus 1. Okay, I write here that is the minus of B of n minus 1 into I. I am taking only LHS side. Okay, A of B of n minus 3 minus B of n minus 2. Okay, means B of plus B of n minus 2 minus B of n minus 2. Okay, all are cancelled. This is the previous one. Okay, then LHS side, finally LHS side is cancelled. The remaining RHS side. What is the RHS side? A of B of n minus 1 is equal to A into I, this one. Okay, after you that, you write here A of n minus 1 is over. Then A of n minus 2, A of n minus 3. Then minus of B of n minus 1, B of n minus 2. Then here comes B of n minus 3. Okay. This one cancel also. Okay. After that, finally write here that is minus B naught of I is equal to A naught of I. That is I, you remove this I means, then let me, that is minus B naught is equal to A naught of I. Okay, pre-multiplying both sides of the above equation. Pre-multiplying means you first multiply I, then A, then A square. Okay, then so on A of n minus 1 into A of n. Okay, I write here. See here, pre-multiplying A means I multiply, first multiply I, multiplying I. Okay, here A of B of n minus 1 is equal to A n of I. Then A is pre-multiplied. Next line is A square. Next line is A cube. Means pre-multiplying is first. Okay. Then A square into B of n minus 2 minus A into B of n minus 1 is equal to A into A of n minus 1 of I. This one. Okay. After that pre-multiplying A cube to this is 1. This equation means that is the A cube B of n minus 3 minus A square B of n minus 2 is equal to A square A of n minus 2 into I. Then so on. After that is the finally an b naught minus an minus 1, that is the b1, means here b naught, after that the b1. Okay, here an is there and a to the power of n means here a to the power of n minus 1. Okay, that is equal to a of n minus 1, then a1 of I. Finally you write here minus of this one, minus of a to the power of n b naught is equal to a to the power of n a naught of I. Okay, then adding these equations means first, second, third, this one, adding this one and this one. Finally you write here, this is your final result. That is, that LHS side is 0. Okay, LHS side we cancel, b of n minus 2, this one cancel, this one cancel, and this previous one, this one, and this one cancel. Okay. Finally, you write here that is the a naught a to the power of n, then plus a1 a to the power of n minus 1 plus so on plus a n minus 2 of a square plus a n minus 1 of a plus a n is equal to 0. This is the equation 1. Okay. Next come to a, hence the square matrix A satisfies the characteristic equation. Okay. This is your theorem. In your, okay, that is this is the 2 mark question. Asking means you only write the statement, this much only. Okay, this is the statement, Cayley-Hamilton theorem. Okay, suppose this is for 5 marks means you prove this theorem. Okay, and you remember this one also. This is the inverse. Okay, A inverse is equal to minus 1 by A to the power of n into A naught A to the power of n minus 1 plus A1 A to the power of n minus 2 plus so on plus A n minus 1 of I. This is the A inverse. Okay, you next come to a example. Okay, this is other method is there. You know that one. Verify the Cayley-Hamilton theorem means first you take the characteristic equation, means that is the first you take the polynomial. After that the a minus lambda phi, determinant of a minus lambda phi is equal to 0. After that a minus lambda phi 0 means you substitute that one a value. After that minus lambda into multiplying lambda to a identity matrix. Okay. See here, your question, first question, verify the Cayley-Hamilton theorem and find the inverse of this matrix. That is the 3 row, 3 column matrix is there. Verifying this one. Okay. First state, that is the 3 row, 3 column. That is element A is equal to 2 minus 1, 1, minus 1, 2, minus 1, then 1, minus 1, 2. This is your question. Okay, verifying means first you take the characteristic polynomial. What is the characteristic polynomial? That is the A minus lambda of I. Okay, first you take the A minus lambda of I means this is the A value. I write here minus lambda of I. Identity matrix, that is 1, 0, 0, 0, 1, 0, 0, 0, 1. Next, multiplying lambda to this one. That means that is the lambda 0, 0, 0 into lambda is 0, 0 into lambda is 0. That's why lambda 0, 0, 0 lambda 0, 0, 0 lambda. Okay. Next come to a simplification. The first element, that is the 2 is there, minus, that is the lambda. That's why I write here 2 minus lambda. Next, subtraction, minus 1 is there, minus of minus plus, minus, okay, minus this minus I minus into 0, sorry, minus 0 means that is the minus 1. Okay. Next, 1 minus 0. 1 is there, minus 0 is 1. Next, come to a second row. Minus 1 is there, minus of 0, that is minus 1. Next, 2 minus lambda, that is the 2 minus lambda additive. Next, minus 1, minus of 0, that is minus 1. Next, third row, 1 minus of 0 is 1. Minus 1, minus of, then this 0 is, that is a minus 1. 2 minus of 1. Okay, that is the 1 is there means that is the lambda is there. Okay, 2 minus lambda, that is I write here 2 minus lambda. Okay, next come to a simplification, that is determinant of A minus lambda is equal to 0. That is the characteristic equation. You know that one. Okay, characteristic equation, determinant of A minus lambda by is equal to 0. Okay, after that you take this A minus lambda value, this value. Okay, so that is the first element, that is the first row, that is 2 minus lambda, then minus 1, then 1, after that minus 1, 2 minus lambda, minus 1, 1, minus 1, 2 minus lambda. Okay, this is determinant of A minus lambda. First you take the determinant, after that you know that one, how to find in the determinant means the plus, minus and plus. Okay, you take the determinant, first you take 2 minus lambda means you neglect means you remove it one, the first row and first column. After that the cross multiply. Already studied this one. Okay, in last chapter the determinant is 4. Okay, that is 2 minus lambda additive, then this one and this one multiplication. Okay, first to first multiply, then first to second multiply. That is 2 minus lambda whole square. Why mean that is the 2 minus lambda into 2 minus lambda, that is the 2 minus lambda whole square. Then minus into minus plus, plus into difference minus, that is the minus of 1. This minus 1, that is the minus into minus plus 1 into determinant minus, that is the minus 1. Okay, plus, that is the, you take here, minus 1 is there, the determinant minus and this minus, that is plus 1. Okay, then come to a second. I take this one, that is the minus plus, that is the plus 1 I write here. After that, you neglect this one and second column. First one, second column. After that, multiplying minus 1 into this one and minus 1 into this one. Okay. I write here minus 2 plus lambda plus 1. Why means that is the minus 2, minus 1 into 2 is minus 2. Then minus 1, minus into minus, that is the plus. Then 1 into lambda is lambda. After that minus, here plus is there, plus into minus, minus into determinant minus, that is the plus. Okay, then plus 1. Don't confuse that one. When you are operating the determinant means, remember that one, you take both elements between the minus sign. Suppose here 3 is there, here 4 is made, you take minus symbol. Suppose we take the matrices means, you take both elements, that is, you take the symbol is, that is positive. When you simplification determinant means, the both element between, you take the negative sign. Next, take this one, that is the 1. Okay, I write here +1. Here plus is there, minus is there, plus is there. +1. +1 means you neglect this column and this one. After that, the cross multiply, that is 1. That is 1 minus 2 plus lambda is equal to 0. After that simplification, 2 minus lambda as it is, then this one, this is a minus b whole square. What is the a minus b? That is a square plus b square minus 2ab. Okay. After that, minus 1 is there. Finally, a simplification, 3 minus 4 lambda plus lambda square. That is the here a minus b whole square formula applying here. Okay. Then this one, that is 1 into 2. Okay, this one. Minus 2 plus 1 is, that is the 1. Okay, minus 2 plus 1 is 1. That is the minus 1. Then I write here plus into minus, that is the minus. 1 into 1 is 1. Then lambda. Okay, this one. Okay, then simplification. After that, finally I write here, that is minus lambda cube, then plus 6 lambda square minus 9 lambda plus 4 is equal to 0. Okay, then you write finally lambda cube minus 6 lambda square plus 9 lambda minus 4 is equal to 0 is the characteristic equation of A. Okay, after that, you know that one. Next step is the lambda is converted to A. Means where lambda is there, you convert, means you write the A. Okay, then they show that A is satisfying the equation, means you convert lambda to A. A means here lambda cube is there. That's why I write here A cube minus 6A square plus 9A minus 4. Okay, I write here only, I write here only constant 4. Okay, next step, you remember this one. You take here I, identity matrix I. This is the little bit change. Okay. Next simplification. Okay. See here. First you take the A cube minus 6A square plus 9A minus 4I is equal to 0. Then first you consider, that is the A square. First you find the A square value. After that A cube value. Which one you want? First you want that A cube. You want A cube value, A square value. You know the A value and you know also identity matrix I value. Okay. First you take the A square. What is the A square? A square means you write here A into A. A into A means you know that one. How to multiply in two matrices means you take the two matrices, that is the A. A means what is the A value? 2 minus 1, 1 minus 1, 2 minus 1, 1 minus 1, 2. Okay. Next, another one A means same take the matrices, that is 2 minus 1, 1 minus 1, 2 minus 1, 1 minus 1, 2. Okay. Next, the multiplication. First, this first matrix, the first row is considered and second matrix column. Means this is the, don't confuse this one. First matrix, that is the first row. Once again, I write here. You consider first row and second matrix first column, multiplying this one. Okay. Then 2 into 2. Okay. 4. I write here directly. Then minus 1 into minus 1. That is the plus 1 minus into minus plus. Then 1 into this 1 into 1. That is plus 1. First row, first column is over. Next come to a first row and second column. Next consider first row and second column. Multiply. Okay. 2 into minus 1. That is 2 into minus 1. Minus 2. Then minus 1 into 2. That is the minus 2. 2 ones are 2. Then 1 into minus 1. That is the minus 1. I write here minus 1. Means that is the first row, second column also completed. Next come to a first row and third column. Many students complete here only first row and third column. That is very easy. That is 2 into 1 is 2. Then minus 1 into minus 1. That is the minus into minus plus. 1 into 1 is 1. Next come to a third one, that is the 1 into 2 is, that is 2. I write here 2. Means first row, third column also completed. Next come to a first row is 4. Next come to second row. Same as second row, first column. Next second row, second column. Second row, third column. Okay. See here, second row, first column is, that is the minus 1 into 2, that is the minus 2. Then 2 into minus 1, that is the minus 2. Then minus 1 into 1 is, that is minus 1. Means that second row, first column also complete. Next go to a second row, second column. Second row and second column. That is 1, 4 and plus 1. 1 plus 4 plus 1. Okay. Next, second row, third column means, that is, I say directly, that is minus 1, minus 2 and minus 2. That is second row, third column complete. Okay. Next go to a third row. Third row, first column. That is 1 into 2 is 2. I write here 1 into 2. Okay. Next come to a minus 1 into minus. That is the minus 1 is there. Minus 1 into minus 1. That is the plus 1. Then 2 into 1 is, that is 2. Okay. Next come to a next third row and second column. Third row and second column. That answer is minus 1 means that is the 1 into 1. That is the minus 1. Here plus 1 is there. Plus into minus minus. That is the minus 1. And minus 2. Minus 1 into 2 is minus 2. Then 2 into minus 1 is minus 2. That is the third row, second column complete. Next come to a third row and third column. Third row, third column is 1 into 1 is 1. I write here. Then minus 1 into minus 1. Here plus 1 minus into minus plus. Then 2 into 2, that is 4. Okay, after simplification, 4 plus 1 plus 1, that is the 6. Then minus 2 minus 2 minus 1 means, that is the minus 5. All the minus is there, adding that element. Next 2 plus 1 plus 2, that is the 5. Okay, I write here 5. Then minus 2 means, that is the minus 5. Then 1 plus 4 plus 1 means, that is the 6. Then minus 1 minus 2 means, that is the minus 5. After that 2 plus 1 means, that is the 5. Then this one minus 2 means, that is also a minus 5. Finally 1 plus 4 means, that is the 6. Okay. This is a square value. A square means 6 minus 5 plus 5 minus 5, 6 minus 5, 5 minus 5, 6. Okay, this is a square value. Okay, next you find the a cube value. What is the a cube value? You see here, it is a cube means you take the a and a square value. What is the a? Already given the a value. This is the a element. Okay. Next, you find a square value. This one, a square into a. Okay. This is the a square. I take here a and this is the a square value. Then simplification means you take the multiplication. Next, you go to here. 6 to the 12. Then you go to this. You consider this is the row and this is the column. Next, minus 1 into 5. That is the minus into minus. That is the plus 5. Then here 1 into 5. That is the plus 5. Same as first row, second column. First row, second column. And first row, third column. Okay. Next come to a second row, first column, second row, second column. I write here. Okay. Next second row, third column. This simplification, you do this one. Okay. Next come to a third row. Third row means third row, first column, third row, second column, and third row. This is third row and third column. I write here. Okay. Finally come to here. That is the a cube value. What is the a cube? 12 plus 5 plus 5 plus 5 10. 10 plus 12 is 22. Here minus 10, minus 6, minus 5 is there. Okay, all are minus sign. That's why we add that one. That is the 10 plus 6, 16, 16 plus 5. That is the minus 21. Next one, 10 plus 6, 10, 16, 16 plus 5. That is the plus 21. After that, same as here minus 21. Then here 5 plus 5, 10, 10 plus 12, that is the 22. Okay. Next one, that is the minus 5, 10, that is the minus 6 is there. Minus 10, minus, that is minus 16, minus 16, minus 5, that is the minus 21. Okay. Next one, 10 plus 5 is 15, 15 plus that is 21. Next is same as, that is also minus 21. This is 12, or that is the 10. 10 plus 12, that is 20, 22. That is A cube value. A square means that was A square value. This is the A cube value. Okay. You remember this one? This is first you consider A minus lambda phi. After that, you find A square value and A cube value. Okay. Next come to A. You are consider this your given equation, that is A cube minus 6A square plus 9A minus 4I. Okay. This means you consider already the A cube value, A square value, you know the A value, okay, then I value. You 9 multiply to A and 4 multiply to I, identity method. Okay. I write here, this is the A cube value. A cube minus 6 of A square, this is the A square value. Then plus 9 of let A value, this is the A value. This is the 4 into, this is the identity matrix I value. Okay, next multiplying 4 to this one means this is the 4, this is also 4. 4 into 0 is 0, 0. Okay, after that 9 multiply to this one. 9 to the 18, 9 1 the minus 9, then plus 9. Okay, then simplification. See here, that is first you subtract and add means first element is subtract add to second one. Okay. Here there is 22, that 6 is the 36, then come to here 9 to the that 18, then fourth one, that is the 1 into 4 is 4. I write here 22 minus 36 plus 18 minus 4. Okay, this is the first element. Next come to a second element, same as second element means this one, minus 21. Minus 21, 6 by the 35. Okay, it is minus 22 minus plus 35. Okay, sorry, 30. That is the I write here minus 21, 6 by the 30. Then come to here, that is the 9 1 the minus 9. Okay, then here 4 into 0 is 0. Next third one, that is the 21 is there. 21 minus 6 by the 30, that is the minus 30. Then come to here, 9 1 the 9. Then 4 gives the 0. This is first row, 3 element is 4. Next come to second row. Second row means that minus 21 is there. Then I write here, then 6 by the 30, the minus into minus plus 30. I write here 30. Next come to a third one, that is 9 to the. Sorry, minus into minus, so plus into minus, minus, that is 9 into 1 is 9. Then 4 into 0 is, that is 0. Same as next third one, and next come to a third row. So this is also multiplied to this one, add means add and subtract. Okay. Finally, you got here, that is minus 36 is there, minus 4 is there, that is minus 40. 22 plus 80, that is also plus 40. Plus 40 minus 40, that is 0. Next one, minus 21 minus 9, that is the minus 30, that minus 30 and plus 30 cancel. That is also 0. Okay, next come to it. Here, plus 21 plus 9, that is the plus 30. Plus 30 minus 30, that is also a 0. I write it 0. Next second row, minus 21 and minus 9 is there. That is the minus 30. Minus 30 plus 30 cancel. That is 0. Next come to a second one. Second row, second element. That is a minus 20, 22 minus 36 and minus 4. That is a minus 40. Then 22 plus 18, that is plus 40. Minus 40 plus 40, that is also 0. Okay, same here. Come to here. This is also 0. 9 plus 21, that is a 30. Okay, then after that, come to here. That is minus 21, minus 9, that is the minus 30. Minus 30 plus 30 cancel. Then 0. Okay. Next come to here. Last one, 22 and 18. Okay, 30, that is the 40. Okay, minus 40 plus 40, that is also a cube. Means finally that is the null matrix. Therefore, you write the A cube minus 6A square plus 9A minus 4I is equal to, that is the 0. Okay, 0 means that is the null matrix. Hence, the square matrix is satisfying the characteristic equation. To find A inverse, okay, next step is finding the A inverse. See here, what is the A inverse mean? You know that one. What is the A inverse equal to A inverse is equal to I. You know that one. Okay. See here, first you take this equation and pre-multiply 1 by A inverse. Means the multiplying this equation to that A inverse. Means A inverse into A cube. Means multiplying here A inverse. A inverse into A cube minus 6 into A inverse into A square as it is. Okay. After that 9 into A as it is, A inverse multiplying this one. After that minus 4 into A inverse of I is equal to 0. Means multiplying A inverse to all the elements. After that, you know that one, A inverse is equal to I. Okay, here A inverse is there. 1 A inverse means that is 1 by 1 A is over, means A inverse means you write this one also, that is 1 by A. Okay, into that is A cube. Means 1 A is cancelled, remaining is A square. I write here A square. That is, after that here 6 into 1 A cancel, then only 6A plus 9 into I. A is equal to, it is I is here, minus 4 into A inverse of I. Okay. Next go to A inverse. We want A inverse means this one. You write here A inverse is equal to, I shall come to this side means that multiply 4 to come to this side, that is 1 by 4. Okay, into that is the A square minus 6A plus 9I. Okay, what is the A inverse? A inverse is equal to 1 by 4. What is the A square value? A square means this one. Already find this A square value. Then minus 6 into, what is the A value? Given the A value, then that is the 9 into I. That is the identity matrix. Next simplification, then have, that is the 1 by 4 as it is. Then the first element. 6, then here 12, then here 9. That is, I write here 6, then 6 to the 12, then plus into minus 12, plus that is the 9. Next element, they have minus 5, then 6 into minus 6, that is minus 1, minus into minus plus, 6 1 plus 6. Okay, I write here plus 6. Next here 9 into 0 is 0. Okay, finally you write here, that is 1 by 4, both the simplification, addition here, 9, here 6 is there. Okay. 6 plus 6, here minus 12 is there. Okay, means that is the 6, that is the minus 6. Okay, 12 minus 6, that is 6. Okay, minus 6 plus 9 means that is the 3. I write here minus 3. Same here 6 is there, minus 5 is there. 6 minus 5, that is 1. 6 minus 5 is 1. Next, minus 6 plus 5 is there. That's why minus 1. Biggest number sign is minus is there. That's minus 1. Same minus plus 6 minus 5, that is the plus 1. Then 12 minus 6, that is the minus 6. Minus 6 plus 9, minus 3. Okay. Come to here, that is the minus 5. Minus 6, that is the biggest number sign plus is there. 6 minus 5 is 1. Next, last row, 6 minus 5, biggest number sign minus is there. That is the minus 1. 6 minus 5 is minus 1. Then here, 6 plus 6 minus 5 means there is a plus side, plus 1. Okay. After that here, 12 is there. 12 minus 6 is minus 6. Minus 6 plus 9, that is 3. Okay. Next come to here, the multiplying 4 to a all element. Means you take there minus 3 by 4, 1 by 4, minus 1 by 4, that is 1 by 4, minus 3 by 4, then 1 by 4, minus 1 by 4, 1 by 4 and minus 3 by 4. Means multiplying 4 to a all element. Okay. This is your A inverse. See here. Next example, this also is there. Here 3 rows, 3 columns is there. You do this one. This is the verifying the Cayley-Hamilton theorem for here 3 rows, 3 columns is given. 1, 0, 2, 0, 2, 1, 2, 0, 3. This is your matrix. Okay, first you take A is equal to, that is the matrix. After that, you take the A minus lambda part. Then this is the characteristic polynomial. After that is the characteristic equation. You take A determinant of A minus lambda pi is equal to 0. After that, the simplification. Finally, you got that is the lambda cube minus 6 lambda square plus 7 lambda plus 2 is equal to 0. This is the characteristic equation. Okay, next you convert that lambda into A. A means you write here A cube minus 6A square plus 7A plus 2I is equal to 0. Okay, next find that is A cube value. After that A square value. Okay, see here. First you take the A square value. Find the A square means. What is the A square final value? That is 0, 5, 508, 245, 8030. That is A square. Next finding A cube value. A cube means you take the A square value and A value. Then multiply. Same question. Okay, this is also is there. And the finally A cube means 21, 0, 34, 12, 8, 23, 34, 0, 55. That is A cube value. Next, you consider the given equation. What is the given equation? That is A cube minus 6A square plus 7A plus 7A plus 2I. Okay, you know the value of A cube value, A square value, and A value, and I value. I write here, this is the A cube minus 6A square plus 7A plus 2I. Okay, after that simplification, just see here, the finally write the simplification means the last is that is the null matrix. Finally got a null matrix. Okay, therefore you write here A cube minus 6A square plus 7A plus 2I is equal to 0. This is the characteristic equation. Therefore, you write here thus A satisfies the characteristic equation. Then therefore, hence the Cayley-Hamilton theorem is verified. Verified means finally you got 0, 0 null matrix. That's what that is the verified. Okay. You do this question, and another one is that is the 2 rows 2 column is there. This is also is there. Method only verify the Cayley-Hamilton theorem of I given 2 rows 2 columns. Means A is equal to 3 1 minus 1 2. Okay, you find A square and A cube value. Also example that was here. Here one equation is given. LHS side is equal to RHS side. Okay. Means first you take the LHS side, after that you find RHS result. See here, first I take the A value, after that A minus lambda pi, that is the characteristic polynomial, then the multiplying A, then my lambda to A identity matrix, then the simplification, finally you got lambda square minus 5 lambda plus 7 is equal to 0. This is the characteristic equation of A. Okay. Next go to, then the lambda is converted into A. Lambda is converted into A means this is the A square minus 5A plus 7 of I. You take I. You don't forget this one. You take I, identity matrix. You consider this one. After that, you find A square. A square means A into A. This is the A value. This is also A value. This is the row and column multiplication. After that, finally, you got A square value. A square means 8, 5 minus 5, 3. This is A square. Okay. Next, go to, that is the equation. A square, I take this one only. A square minus 5A plus 7I equal to 0 is there. Okay, first take the A square value minus 5 of A value. Then 7 of I. It is the identity matrix. Okay. Finally, you got this one. Finally, you got null matrix. Okay. Null matrix means you know that one. R the element is it is 0 0. It is null matrix. Okay. Finally, you telling that one. That is the a square minus 5a plus 7i is equal to 0. Hence, the Cayley-Hamilton theorem is verified. This is for 5-mark question. Next, go to here. That is the first equation. You take here. That is the a square minus 5a plus 7i is equal to 0. That is the verified Cayley-Hamilton theorem means first you take the first one a square as it is, then minus 5a plus 7i come to the other side means that is the plus 5a minus 7i. Okay, this is equation. That is a 2. This is the equation 1. Equation 2. Right, next go to a cube means you take a cube is equal to that is the 5a square minus 7ai. Means multiplying a to a square. Okay. Next a4 means the multiplying a to a cube. That is a4 is equal to 5a cube minus 7a square. That is the equation 4. Next equation 5 means that is the multiplying the a to a equation 4. That is the a5. A5 is equal to 5a4 minus 7a cube. Okay. Next simplification here a square. What is the a square value? You find 8 5 minus 5 3. Already find this one. Then a cube means that is the 5 into the equation that is 5a square. What is the a square? 8 5 minus 5. This is the a square. Okay. I write here a square value 5 into a square. Okay. Then that is the 3 1. That is the 8. It is a square, it is 8. Then multiplying this one, both multiplying means that is the 40, 25, minus 25, then 50. Minus, okay. That is finally got 19, 80, minus 18, and 1. It is a cube value. A square means 8, 5, minus 5, 3. Then a cube means 19, 18, minus 18, and 1. Okay. Next go to a. Then your question asking here the LHS side that is the 2a to the power of 5 minus 3 a to the power of 4 plus a square minus 4i. Okay, this is LHS side. First you take 2 as it is the number. After that what is the a5 value? You know that one a5 value that is equation 5. That is the a5 value. Then minus 3 into a4 value plus a square minus 4 into that is 4i as it is. Okay, that is I write here that is the 5. 4 5 means I take here this is the 5 picture. Next simplification. Okay. 5 to the 10 a4 minus then 14 7 to the 40 a cube multiplying 2 to a this one. After that here a4 is there. It's also this 4 is there. Okay. That is finally write 7 a4 minus 14 a cube plus a square minus 4i. Okay. Next come to a4. Next simplification. What is the a4 value? This is the a4 value. A4 means 5a cube minus 7a square. Then simplification, we got this one. 21a cube minus 48a square minus 4i. Okay, that simplification means that next go to a cube. You substitute a cube value. A cube means 5a square minus 7a. This is a cube. Next simplification, you got this result that is 57a square minus 147a minus 4i. Next go to a square value. You substitute a square value. What is the a square value? 5a minus 7i. Okay, multiplying it 57 to 5. Then after that multiplying to minus 7. Finally got that result that is RHS side 138a minus 403i. That is RHS side. Means LHS is equal to RHS side. After that you go to finally you write here 2a. You write here 2a to the power of 5 minus 3a to the power of 4 plus a square minus 4i is equal to 138a minus 403. of I. This is verifying the Cayley-Hamilton theorem.